Good morning. Today we're going to be talking about slope triangles and why they are similar. 7.6. We should be able to graph triangles on a coordinate plane, write and solve proportions using the rise and run of slope triangles, identify similar triangles, and then relate the slope of a line to similar triangles. Okay, so slope triangles are triangles whose hypotenuse fall along the same line, forming two pair of congruent angles, resulting in similar triangles using the AA similarity. And this is what we worked on yesterday. So if I have a line and these two right here, these two triangles are created from my line. Let's see if I can. So we have this angle, which is going to be the same, and this angle is the same. This angle, and then of course our right angle. We only needed two angles, and that means this triangle is similar to this triangle. So here, remember BAC, that's here, is this one, and DBE is this one. These two, and they are congruent. And then we have the other ACB, which is ACB, this one, and BED, which is this one. If they're congruent, then we have a triangle that is similar. Okay, so first, we have a few steps that we have to do first. So graphing M and O with the vertices 3, 1, so over 1, 2, 3, and up to 1. 1, 0, so 1, 0, and 3, 0. And then we're going to graph PQR. So P is 5, 2, so 4, 5, 2. Negative 1, and maybe I'll change this color actually. Negative 1, negative 1, and 5, negative 1.
Good morning, everyone. This announcement is for the students that have Miss Quick. She is now in her room. Can you please come to the office and I will give you guys a pass for your project. Thank you.
Okay, and then I'll go ahead and I'll write. There we go. Okay, then write a proportion comparing the rise to the run for each of the similar slope triangles and find the numeric value. So rise to the run. So let's see if I can. Started this without knowing that I started this. Anyway, so writing the proportion of the rise to the run. So our first triangle here is our black one. Our rise is 1 and our run is 2. So it would be 1 over 2. And then our red triangle, our rise is 1, 2, 3. And this one is 1, 2, 3, 4, 5, 6. So it would be 3 over 6. And those two are equal because they both reduce down to 1/2. So reducing it down to 1/2. Alright, our next problem, graphing ACG with the vertices 1, 4, 3, negative 2, and 1, negative 2. Try and make these the, oh gosh. If only I had a ruler. Okay, it's a little terrible, that's okay. Alright, and then BCF with the vertices 2, 1. So 2, 1 goes here, which would be on that line. 3, negative 2, 3, negative 2, and 2, negative 2. Then write in a proportion comparing the rise to the run. We'll start with the blue one. So I have a rise of 1, 2, 3, and my run of 1. Does that equal tried to change the color and it didn't change. My rise here of 1, 2, 3, 4, 5, 6 over 2. 6 divided by 2. Now I do need to see that here, if I go from here down, it's going to be a -3 and a -6 because I have a negative slope here. So it is going to be reduced down to a -3. So this is a -3 here. Okay. Finding the numeric value, reduce down. Alright, similar triangles and slope. The ratio of the rise to the run of two slope triangles formed by a line is equal to the slope of the line. So this slope here is going to be a -2. Smaller triangle, -2. If they're similar, the ratio will be the same. Okay, so the plans for a teeter-totter are shown at the right using points G and L. Find the slope of the teeter-totter and then verify that the slope is the same at different locations by choosing a different set of points. Okay, so let's do answers are shown using points G and L. Find the slope. So G to L. So that would be rise would be 2. My run would be 1, 2, 3, 4, 5, 6. Okay, which reduces down, we know, to 1/3. Now I'm going to go, we could do G, let's do a different color. Let's go G to H. So G to H is the rise is 1 and the run is 1, 2, 3. And then let's do, how about the biggest one? So let's do G to K. So I'm going to go up 1, 2, 3. And I'm going to run 1, 2, 3, 4, 5, 6, 7, 8, 9. So 3 to 9, which we know reduces down to 1/3. They're all 1/3. So we know, then we verified it. Okay, so now the plans for a set of stairs are shown below using the points X and Y. So I have X, X, and Y. Find the slope of the line down the stairs.
Dave Feist, please come to the office. Dave Feist.
So 1, 2, so X to Y. So X to Y, since I did that, I could go down 2, but it would be either up 2 over 3 or down 2 to the left 3, which reduces down. A negative divided by a negative is a positive. So X to Z. God, I already messed up. So we have X to Z. So using those points, find the slope of the line.
Can I please have the following students to the office, please?
4.
Sydney Heinert, Madison Berger,
4.
Ellie McElveen, and Kaylee T.
1,
Ward.
2,
To the office.
3,
Thank
4,
you.
5, 6, which reduces down to 2/3. So that's X to Z. And then we want to verify using the slope at the same slope. Verify that the slope is the same at a different location by choosing a different set of points. So we'll use a different color. Let's go, this is where I would choose one that's really close because that's going to be a simplified. So up 2 and over 3. So Y to X is rise 2, run 3. And then let's do pink. And let's do Oh, let's do the big one actually. Z to W. So we rise 1, 2, 3, 4, 5, 6. And run 1, 2, 3, 4, 5, 6, 7, 8, 9. Which we know can both be divided by 3, 2/3. Alright. Your assignment, page 565, 139 through 17 on. And you can do it in your textbook. Number 9s and 15s, you need to make a graph. The ratios of the rise to the run should be same if they are similar.